Okay, so this problem is looking at the caller conventions for ARM assembly. We can recall that R0 through R3 and R12 are caller saved, and R4 through R11 are callee saved. So what that means is that if I am calling some function, in this case func1, or if func1 is calling func2, I have to assume that anything I have in R0 through R3 or R12 might be changed by that function. And so if I want to keep that value, I need to make sure I push and pop it. Push it before I call the function with BL, pop it after I call that function to get the value back, right? Because that puts it on the stack. Pushing it puts it on the stack, saves the value for me. Popping it pops it off the stack, gets the value back for me. We're sort of assuming that pushes and pops happen as, matching pairs. So it basically just saves whatever's there currently and then brings it back. So we look at main here and see that I put some value into R1, I put some value into R4, and then I call this func1. So after that, I use the value in R1 and R4, and I use some values in R2 and R0. So I can assume that those were set as well, or those might be set by the function in this case. So here, R1's kind of the critical thing, that I'm using it after and I'm setting a value before the function. So I kind of have to assume that, like, if I wanted that value, if I'm using it in this add, I kind of want that value most likely. So I wanted to save it, and that means that since I can't assume that func1 is actually going to keep that value the same, whether or not it does change it, I have to push it and then pop it afterwards. And so I'm going to push R1 and then pop R1. Theoretically here, since I have R0 and R2 as some values as well, I might want to push and pop R2. R0, I might know that that's actually a return value from func1. Since that's this sort of standard calling procedure, is that parameters go in 0, 1, 2, 3, and then return values go in R0. So I may also have wanted to save or no, I don't need to save R2 because that gets modified there. So we kind of just want to trace back here and see, like, what inputs to stuff after I called this function did I set a value for before that function, and that's what I would want to push and pop. I can look at func1 here too and see that I have a value, or if I'm going to modify the value in R4, I know that because I'm a function, because I'm a procedure, I'm not allowed to modify things from R4 to R11 without saving them first. So this is basically like a nicety that the function does to ensure that I don't mess with something that the main function wanted to keep. So since I'm going to put something in R4, I'm going to push the value of R4 and then I'm going to pop it whenever I'm done, and that way I can restore it for the main function. So that move R4 1 that the main function did, I'm basically making sure that I don't get rid of that 1 so that I don't overwrite it. I also have to push LR because I'm doing another BL. And we have to remember that BL implicitly writes to LR, and LR is where I'm going back to. So when I called BL func1, that sets the link register to point to this next instruction, this pop here. Whenever I call BL func2, that sets the link register to point to this move. If I don't save the link register, I can never get back to the main procedure. I'll always be stuck in function 1. Unless I happen to be able to otherwise recover it, but I shouldn't have to do that. That's kind of what the stack is for, is because I can save this link register. I can save that return address so that I can get back to my main function. Optionally here, if I wanted to save R0, I could push it and then pop it before I call BL func2. And func2 doesn't actually do anything that it's not allowed to do according to the calling conventions, so it doesn't have to push or pop anything. So the real thing to remember here is that R0 through R3 and R12, if I want to save those from the function I'm calling, if I don't want the function I'm calling to modify those and get rid of the values I have to push and pop them. If I'm a function, if I want to use R4 through R11, I have to be nice to the thing that called me, and I have to save those values in R4 through R11. So those are the two rules to sort of abide by. Otherwise, the good things to know are that R0 is the return address, R0 through R3 are usually the parameters. So if we were doing something, for example, like interfacing assembly in C code, those were the extra things that I would have to know.